Hello, everyone. Today, I will present our final project on Japanese multi-speaker text-to-speech conversion using the JVS databases. First, let's have a quick recap on the proposal. The objective of this project is to develop a reliable multi-speaker TTS system. The system architecture comprises three main components. The first is a speaker encoder trained as a speaker verification task, utilizing the JTube speech corpus, which contains 484 hours of recording from 1,792 speakers. The second is a synthesizer based on Tacotron for text-to-spectrogram conversion. This is using the JVS corpus with 30 hours of speech from 100 professional speakers. Lastly, the VO coder is used to transform the spectrograms into audible waveforms, either using data from the JSUT corpus or leveraging a pre-trained model. This slide shows the workflow chart. We first obtain a pre-trained VO coder, and then we train the synthesizer using the JVS dataset as planned. And lastly, we train the speaker encoder using the LibreSpeech dataset instead of the JTube speech corpus we initially planned. The main reason we are using LibreSpeech instead is because we face significant challenges in training the JTube dataset. This dataset is likely crawled from YouTube channels, and its quality is not very good. It has a lot of empty audio files in itself, and a lot of speeches has excessive background noise and background music. And the model trained under the JTube dataset suffers from it and is not very satisfactory to me. Thus, I have to choose another dataset. I choose the LibreSpeech, which is an English dataset. The primary reason is that I wanted the encoder to be trained for at least around 1,000 users, and there isn't any other open source Japanese dataset that has this many except JTube, and JTube is not very good. Ideally, the speaker encoder should only capture speaker-specific features that are language independent, but and obviously we shouldn't really suppose that, and the drawback is obvious. The differences in the rhythm, stress, and intonation between Japanese and English is very big, and this can definitely be detrimental to the naturalness of our synthesized speech. These slides contain samples from different speakers speaking the same text. Let's hear about it. This is the text, and these are the three synthesized speech.
週末には家族と一緒に山にハイキングに行きます。自然の中で新鮮な空気を深呼吸するのはとても心地よいものです。晴れた日には遠くの景色もきれいに見えます。週末には家族と一緒に山にハイキングに行きます。自然の中で新鮮な空気を深呼吸するのはとても心地よいものです。晴れた日には遠くの景色もきれいに見えます。
週末には家族と一緒に山にハイキングに行きます。自然の中で新鮮な空気を深呼吸するのはとても心地よいものです。晴れた日には遠くの景色もきれいに見えます。
We can notice some random intonation changes across the speakers from the same input script. But I want to stress that this issue is relatively rare, and I choose this example just to point out there is such a problem. And these slides contain samples of different speakers and the comparison between different speakers and their original voice. And I would say that the effect of extracted speaker embedding is not as strong as anticipated. Let's hear about it. This is the original voice, and this is the synthesized speech.
ハロウィンに参加するには、こういう服を着なければならないと聞いたのです。指揮官、今の綾波は可愛いですか？
明日は私の誕生日です。友達と一緒にレストランでお祝いします。特別な日なので、新しいドレスを着ていきます。みんなで楽しい時間を過ごすことを楽しみにしています。
作者は会社と日々の生活の表情との違いを埋めるものとして詩を書いてきたと語り、人は転勤の時にサラリーマンを離れた表情を持つという。明日は私の誕生日です。 友達と一緒にレストランでお祝いします。特別な日なので、新しいドレスを着ていきます。皆で楽しい時間を過ごすことを楽しみにしています。
You can hear from the speech, especially the second one, there's like evident differences between the input speech and the synthesized speech. And one reason can definitely be the speaker encoder is trained in English instead of a Japanese dataset. And another cause maybe we are using a pre-trained view coder and its alignment with the output of the JVS trained synthesizer may not be optimal, and any discrepancies in the spectrogram characteristics between what it has been trained on and what it received from the synthesizer can definitely affect the final audio quality. That's all. Thank you so much for listening.